Hello team, this challenge is Unnatural Prime, where we're given a number and we need to decide if it is a prime number. And a prime number is usually a positive number greater than 1 that is only divisible by 1 and itself. I say usually, I mean always, right? So it's always only divisible by 1 in itself. In this case, we are doing negative numbers, but the negative numbers, we need to convert them to their positive form, right? So there's a little bit of something happening in there. And of course, ignoring that one because that's the one that makes this unnatural, 1 and 0 are not considered prime numbers, right? One divided by 1, it's 1 and itself. Maybe, right? You could argue it, but technically there's 2 ones in there. So it gets special for reasons that are beyond this video, okay? So with that, this is not the first time that we've seen prime numbers. I'm going to take a wild stab and say that this probably is back in January 9th. Way back in January, we did circular prime, where we had to determine if all the variations of a number while rotating the number, so 197, 971, 719, if they were all prime. And for this, the key to this was determining prime numbers, right? That was the whole thing. So we created a helper function right here called isPrime. It went through, again, it checked for anything that it was 1 or less because you can't do negative and you can't do 0 or 1. If it was any of those, it returned false. Otherwise, we went through, we did some work, and if we were able to get through all this, then we return true. Otherwise, we return false, right? That's the one of the most efficient ways to get this done, especially with math square root. Well, magic of magic, right? We can actually use this. So if I take this and bring it over to this code, I can totally reuse that right here, okay? And then down here, the only thing that I really need to do is take that n and go isPrime math.absn, right? At which point we are done. So again, if you already have this isPrime function, you can reuse it in very different ways, right? We've used ABS, which is short for absolute, to flip the number to its positive version, and then we ran the system and did it. Now, one thing that I learned since doing that circular prime challenge is that every time I go through the loop, I'm actually recalculating this math.square root. So there is an optimization, there is an optimization here where we could take this out, cut it, let's call it root, and then right here we can calculate that ahead of time. It's a small thing. It's not really going to do a lot for the numbers that we're working on, but if you're doing something huge, this might make a difference, right? It's such a small thing, but it might make all the difference depending on how high up you're running this isPrime function. Okay, so that's it for today. Again, we reuse some code from before, right? We use this isPrime function. It's very handy. I suggest you clip it, you snip it, you store it somewhere for later, right? And you have it handy because if you ever need to calculate primes, you're going to do some version of this. So why invent the wheel, right? You already have it. We did a little bit of a micro optimization inside of there, but this calculates isPrime, which is any number greater than 1 that is only divisible by 1 in itself, right? And then we use math.abs to calculate if negatives could also become primes. That's all, right? That's the whole thing. Did you like it? Did you hate it? Did you go a different way? Let me know all that stuff in the comments. Otherwise, for today, this has been Unnatural Prime, and I will see you in the next one.